The next two talks came from some of our triage calls on Monday morning, and sometimes we get these wonderful translational medicine proposals, and sometimes we get some not so wonderful translational medicine proposals. So Ann Schott had suggested that perhaps we show the process of developing these TM protocols, and Dan's going to give a broad overview of putting together a TM protocol, and then Lucky Lara is going to talk about the triumphs of working through a TM protocol. So I don't think I need a long introduction for Dan. Dan, just short, congratulations on being elected ASCO president. Clearly you have the respect of your peers.
Thank you, Lee. For those of you I promised I would pay if you voted for me, the checks are in the mail. And for those of you who are from the NIH and the government, I'm just kidding, okay? I really Actually, it was a pleasure to follow Jeff Abrams. He and I grew up together in the CLGB. We were kids together. He's gotten old. I haven't. That's reassuring. But it's great. Jeff's been a terrific supporter of translational medicine. What many of you don't know is if you have followed what we've been able to do in breast cancer over the last 20 years, it's because we've had enormous numbers of breast cancer tissues collected and archived and stored in the cooperative groups. That was Jeff's doing, and without Jeff's work, we would never have been able to do that. So we owe him a great credit, yes. And my final words of introduction is this is the first time in my life I will be more wonky than the statistician who just preceded me in my talk. It's a little worrisome to me. Okay, I have a lot of conflicts, but nothing related to this presentation, and if you'd like, I can go through them, but I won't. Okay, this is very similar to what Dr. LeBlanc just said. Why are you doing this? And I frequently ask colleagues this, what's the point here? Are you doing it to change practice? That's what we're supposed to be doing. Are you doing it to gain biological insight? That's okay too. That's the exploratory stuff that Mike just talked about. Or are you doing it just to get promoted? And while that's okay, that's not really what we're trying to do. Some of you may know that I love Scotland, and this was a tombstone of an indentured laborer who had just helped build a dam in the early 1900s and died. And his tombstone says, "Not known." And I think that's all of our fears, that we'll die in our tombstone, no one will even know who we are. I get it. I understand that. On the other hand, what we're really trying to do is to change practice, is to do something that's meaningful, and that's what a lot of this talk is going to be. This year in the United States, more than 250,000 people will be diagnosed with breast cancer, 50,000 women will be treated for metastatic disease, and all of them will get some level of personalized therapy, perhaps in breast cancer more than others, arguably because of the ER and HER2 knowledge. But most of them are still going to get a one-size-fits-all. We can do better. It's not fair to our patients, and that's what we're all here for. So when is a marker clinically useful? And this is kind of what you were just talking about as well, but A, that you know how to use it. I probably get one call a month from someone, usually in a really great lab, who says, I need breast cancer tissues, and I say, well, what for? And they say, because I have a marker for it. And I say, what do you think it'll be useful for? And the answer is usually breast cancer. And usually there's a long silence on the phone where I say, and what? So, in the most cases, as Mike already said, we're trying to either develop prognostic or predictive models that would be helpful for us to decide if a patient needs subsequent therapy and if the subsequent therapy we think we're going to use is going to work, so-called context use. The second is that the magnitude of the effect between those who are positive and those who are negative for the marker is sufficiently large that those of us who wear white coats and take care of patients, those of us who are patients, would want to use those data to make a difference, either because we have a greater chance of benefit, or more importantly, frankly, that we have no chance of benefit, either because we don't need something or it's not going to work, or because we have a smaller toxicity rate risk and we're willing to take it. And finally, that the estimate of that magnitude is reliable, and that depends on two issues, analytic validity and clinical validity. And I'm going to talk a little bit about analytic validity because it's something that we often forget to discuss. And is that a good assay? Frequently, we see assays come to us from mom and pop academic labs, like my own, where people haven't really thought about the pre-analytical issues. Was that tissue handled in a way that the assay is actually going to work in the kinds of tissues that we collect in the cooperative groups, in SWOG? So, for example, if you have an assay that's only going to work in fresh frozen tissue and you want to test it retrospectively in a breast cancer model, you're not going to get those tissues from us because all we have is FFPE. So you really have to think about the pre-analytical issues, and you also have to think about whether the assay you have is reproducible, reliable, accurate, whether more than one person can do it. These are all issues that are really critical that often don't come through in the concepts that I see in the first branch. The second definition is clinical or biological validity. That just means you've separated it into two groups. That may help you with biology or help you get promoted. It's not going to help you take better care of patients. What we really want is an assay that has clinical utility, and that is, do the results of the assay lead to a clinical decision that's been shown with high levels of evidence to improve outcomes? How do we get there? About 4 years ago, because of the unfortunate circumstances that happened at Duke, the IOM put together a committee at the request of the NCI and others to actually look at omics-based predictive tests, but frankly, these apply to everything. And probably the most important thing that came out of that committee was this roadmap going from left to right, where on the far left, you've got a great idea and you think this is really going to work. In the middle, you build a test for the biomarker. Remember, a biomarker is not a test. A biomarker is a biomarker. There may be many tests for that biomarker, and each one of them needs to be figured out both analytically, and then ultimately you cross that line and you decide, does this really have clinical utility? Do we really have high levels of evidence that using this assay results in a better outcome for the patients than if you don't use the assay? How do you get there? There are really two ways. One is, whoops, didn't mean to do that. One is by running prospective clinical trials where you test the test. In SWOG, we've been very good about that in the breast cancer program. We've run SO500, Jeff Smirage's CTC study. We're now running the responder trial. We participated in TAILOR-RX. We're pretty good at knowing how to do that. The other are what are called retrospective prospective studies using previously collected archive specimens from clinical trials. And this is a term that in a paper that I really had the privilege of writing with Richard Simon and Soon Paik, when Rich Simon called me and said, would I be interested in writing a paper with him, I said, how soon can I drop everything else I'm doing? Michael, if you called me, I'd say the same thing. It was a real opportunity for me. And basically what we said is sort of a hierarchy of the kinds of studies you might do, going from a prospective trial that tests the test, like TAILOR-RX or SO500 or S1007, to one in which you do a prospective retrospective study using previously collected but now archived specimens from prospective clinical trials that ask a specific therapeutic question that your science relates to the question, exactly what you were saying. To those that we usually do, which are studies of convenience, where you just happen to have some assays and you happen to have some specimens and you have lunch with each other and you get a p-value of 0.04 and you rush it off the New England Journal and you get a p-value of 0.06 and you put it on the shelf and don't tell anybody. And just going left to right, these are much more likely to give you truth and let you take care of patients better. These are much less likely to and get danger and danger as you go this way. When do you write a crawl of science? Either before it starts or after it's complete. And these are paragraphs out of the NCI thing, and sorry, Jeff, this is not meant to be insulting, but I don't have time to read all these, so this is my interpretation of these. An integral biomarker is one you need to run the trial. Circulating tumor cells were an integral biomarker in SO500. We could not have randomized people if we didn't know what the results of the circulating tumor cells were. An integrated biomarker is one that you think is really important right now when the trial is over. If you have the results, that should change practice. An exploratory biomarker is one that wouldn't be neat if something good happened. And so those are things you want to write in before you write a prospective trial so that you have the data you want at the end. An integrated study is one where you want to wait. Now there are two. One of those, what's the advantage of an integrated biomarker assay prospectively as opposed to waiting until the trial is over and writing a concept using archived tissues? Well, the prospective integrated biomarker studies, you're more likely to get the specimens you want, and you're more likely to get them in the way you want them. Because usually the archive tissues have been collected in the way that we thought was a good idea, and 10 years from now, your assay may require something different. And it's less likely to be important when the trial is finished, often because our trials take 10 years to finish. And what I think is really cool right now probably is not that cool 10 years from now. Believe it or not, the technology has changed in the last 10 years in terms of next-gen sequencing. Like, I never heard of it 10 years ago. And so one of my concerns of writing integrated biomarkers is that you may be locked into assays and biomarkers that you don't care about when the study's done. There's pros and cons of both of these. When to write it after the trial is complete. And that's not applicable for integral. It certainly is applicable for the prospective retrospective studies. You're less likely to have the kinds of specimens you want or the way you want them, but you're more likely to be important when the study is over. So the elements of a good concept are really just like a therapeutic one. What's the question? What's the impact? This is a recurring theme I think you'll hear today. What are the objectives? You have to be explicit, not just to examine the role of HER2 in lung cancer. It's to see if HER2 is actually predictive of prognosis or predictive of a therapeutic response relative to this clinical trial and the question that was asked. You have to also tell what the assays are. In other words, does it have analytic validity? Do you already know the cutoffs? And is there enough clinical validity to suggest that there's a reason for people like me to pull the trigger and say, yes, that's okay? And it is important to actually work with your neighborhood statistician to develop these things. There are a number of links, and I have 5 seconds, which is perfect, to both SWOG and NCI concept sheets that will be very helpful for you. I don't expect you to read this, but here's the website for the SWOG website for use of specimens for translational medicine research. This tells you how to write a good concept. Lee, you want to go over all this right now? Sure. This is just the form you want to use. And then this is the Biorepositories and Biospecimens Research branch, almost an identical website, frankly, that tells you what to do to go to the NCI to get specimens. And finally, this is the new Navigator, which I don't fully understand, but I hope to in the near future. And so that's the website for that. So with that, I'm thankful for the time you've allowed me to give. I'm more than happy to help you write a concept, and let's get out there and do things that change things for our patients. Thank you so much.